Hello guys, there are three types of prediction: fixed point, fixed lead, and fixed interval.
So this is j equals to k plus n. Okay, so for example, k is 1 and n is 5. Okay, then it will be 6. Okay, so using the fixed interval prediction, we can get the predicted value of the state at 6 here. Then x at the next iteration, like k equals 2, then 2 plus 5 equals 7, like here 7. And similarly, when k equals to 3, then 3 plus 5 equals to 8. Then we get the predicted value of k here. Okay, and similarly, here j equals to k plus l. Okay, so when k equals to 3 and your lead is the fixed lead 3, you will get the predicted value at the 6. And similarly, when k equals 4, then you will get the predict value of here the 7. Okay, and similarly when k equals to 5, then you will get the at the scan. Okay, so using the fixed lead and using the fixed lead, you will get uh, the predicted value of the fixed lead with k plus the lead scan. Means k is 5, k equals 5, 1 2 3 4 5. Then after the leading time, you will get the predicted value after the leading time here, like 8. So lead is 3. This is the lead is 3 scan. After the leading, skip the 3 scan and get the predicted value at here. Then the algorithm for the different types of prediction, for example, fixed point prediction, how we can use this fixed point prediction in the algorithm. The fixed point prediction of the state to the fixed time point n from the time k is this one. So don't be confused with this equation. This is the same thing like the your state equation f of k, x of k, and plus f of k and your process noise v of k. Okay, so here we are taking the fixed point prediction. So what is fixed point prediction? The fixed point prediction, you have to replace the k with the n minus 1 minus j. Okay, here also you have to replace this thing because you are performing the transition of the object state at the fixed point. You are performing or you are calculating the object state at a fixed point, so you have to change f of k, the interval, like f of n minus 1 minus j. So when we multiply this matrix to the x of k, then it will give you the prediction of the fixed point. Okay, or the fixed point using this interval. Okay, and similarly the you have to multiply the fixed point the transition matrix to the process night, but as we are taking the expected value, so the expected value of the process noise is 0 because it has 0 mean and white sequence, so it will be 0, and the remaining part is this one, the f of fixed point uh, interval into the estimating value of this thing. Okay, so again this thing is equal to the command filter like this one, like this equation. Okay, so we are uh, this is the xp, the prediction of the prediction at scan k minus 1. So for the k minus 1 you must know the f of k minus 1. Okay, the previous scan which multiplied to the estimated value of the k minus 1 condition on k minus 1 and plus the comma filter again, and this is the residue. As you know, the residue is the z minus z mean. Okay, and this is the fixed point interval. Okay, so how we can write this equation in the recursion version, so which becomes a recursion like this one. um, the this is again the xp. Okay, xp is the what is the predicted value of x at n conditioning on the k minus 1 is k plus the fixed point prediction transition matrix into the command gain and to the process noise. Okay, so the expected value of the prediction to n from I condition on the data through time k. This one means here this equation, this the variable at the left hand side, it means the expected value of uh, the estimate of the n conditioning on I, where I is the data measurement available up to k scan. Okay, so this k is include I less than k, so this k includes the all measurement available up to the k, and you are finding the data available at k to the fixed point n value. Okay, so this is a recursion form, and then the covariance of the state prediction is this equation. So again taking the expectation for the fixed point state, and we will get the p of n condition of k minus p of n condition I. Okay, so here I is greater than k. Then fixed lead prediction, uh, it follows from the previous equation number 14 like this one. This equation 14, just you have to replace this thing with the fixed lead prediction like yeah, n. This you have to replace the n by k plus l. Okay, so in the f matrix you have to replace by k plus l minus 1, and j you have to replace by n by k plus l. Okay, and this is again the this equation is the prediction equations. Okay, and this is obtained by the command filter. So as you know the command filter. Okay, and which is the command filter which is stated that this is the xp at time k minus 1 plus the command gain and the residue, and this is the again in the similar way the fixed lead transition matrix. Okay, now which becomes the recursion form like this one. This is same thing but in the recursion form. The estimate prediction of the state of k plus l condition on k equals to this thing, So the this transition matrix is multiplied with the prediction. Okay, and the k plus l prediction minus 1, k plus l minus 1, and plus this is sum of product of the all values of the uh, state estimate from k up to the leading point. Okay, and the covariance associated with the above follows from the standard propagation equation like this one. This is the again similar to fk p k k f k and transpose. Okay, this is the same thing, just we include the fixed lead format here, fixed lead time sequence inside the bracket. And then the fixed interval prediction. So for the fixed interval prediction, the propagation equation of the fixed interval prediction of the state at time j based on the fixed measurement data up to n. So in this case, uh, you have given the prediction up to n like this. If n equals to 5, so you have already given the prediction of the 5 scan prediction. Now you are calculating the uh, n plus 1. So here j equals to n plus 1. So each time n plus 1, then uh, n plus 2, and so on, and then n plus 3, and so on. So uh, now x of j condition of n means prediction of the scale number 6, condition of the n equals to the f of j minus 1 and x of j minus 1 condition on n. Okay, again this is the same f of x or f of k and x of k condition on n, but uh, as we are calculating the fixed interval prediction, then we have to replace like j minus 1 and j minus 1 condition on n, or we can write here like this one in the product form like this. Sum of product of j plus n minus 1, this is the j plus n minus 1, and this fixed interval prediction and x of n condition of n. Okay, it means you have already uh, calculated estimated value of the each thing. Okay, so here you already known x of. Okay, so you don't need to calculate here using the gamma filter estimator, because you are in this case you already known this thing, and now you are predicting the next scan. So the next scan, for calculating the next scan prediction, you have to use this one f of j minus 1 into this thing. And the associated coverage follows from the standard state prediction covariance propagation equation like this one. Okay, again this is the same thing, f of k p and f of k and plus covariance. Okay,